Okay, so the degree means the highest exponent.
So what would a quadratic have as a degree?
It'd be 2 or 3 exponents.
Quadratic means x squared, so the degree would be...
Oh, 2.
2, because your highest exponent is x squared. What about a linear function?
It would
your
be...
highest exponent be in a linear function?
It would be 1.
It would be 1.
Because linear fractions have no exponents.
Right. You don't have an exponent. It's just mx plus b, x has a power of 1. Okay? What about a constant function? Constant function would just be like y equals 3, or y equals 4, or y equals negative 1.
It would be 0.
We already used degree 1. Constant function is degree 0, because you don't have any x's. Okay? The x's are missing, they really have degree 0. Now there's a couple new ones that have names.
Cubic.
What is a cubic function?
It's x to the third.
X to the third, degree 3. And the only other one that has a name is a quartic function.
Never heard of that one. So, but that would be x4 to the 4th,
It would
wouldn't
be
it?
4, yes. Nothing else has a name.
So
you can make up names if you want.
Would you say x quartic? Or how would you say that?
You would just say it's a quartic polynomial, or it's a quartic function.
Okay, but you just say x to the 4th power when... Okay.
X to the 4th power, yep.
I was wondering if there's another name for that instead of like square root of cubic.
Nope, x to the 4th. Okay, so we need to know the degree. Let's do practice problem. We haven't done practice problem yet today, have we? Alright, so give me a sheet of paper.
Sure. Can we do the group work?
Yeah, you can work in groups if you want.
So do you just want us to tell you the highest, or tell you what kind of function it makes it?
The highest exponent, the degree.
How would we write it down? Degree equals...
Just say the degree is whatever.
Okay.
Alright, what about number 1?
4.
Okay, so I tried to trick you guys by putting this out of order. The highest exponent is here. So I would say that is degree 4. What about number 2?
It's 2.
Number 2 is not a polynomial.
Oh.
That's square root of x. You cannot have that in a polynomial. Polynomials can only have like x squared, x to the third, x to the 4th, x, and constants.
So that'd
and
be...
higher powers. Square root, fractions, anything funky is not going to be allowed. So that
So even if it had said 1/3 x.
1/3 x would have been okay.
Okay.
I mean, like fractions like 1/x or something.
Okay.
Yeah. So you wouldn't be asked a degree of something that's not a polynomial in the first place. Okay? What about number 3?
But they're multiplied by each other, right?
Not 2 or 3. They are multiplied.
Both sides.
You gotta go to your happy place and imagine multiplying this all out. Don't multiply it out, because that would be insane. But this is actually multiplied out. You have x minus 4 times x minus 4 times 2 minus x 3 times. Okay? You'd have to FOIL all of this.
We should just do
You
it.
FOIL 2 of them, and then you FOIL that with the 3rd one, then you FOIL that with the 4th one, then you FOIL that with the 5th one. You're going to have a lot of stuff going on. It would be very, very hard.
We're going to have to do that now.
No. Don't do it. Do not do it. Do not do it.
I was going to say.
Just think. You only care about the highest power. The highest power you could get would just be by multiplying all the x's together. So you just think like x times x times x times x times x, that's x to the 5th.
Or you can simply add. I was going to say, you could simply add them, correct?
Just add the powers, yeah. You're multiplying them. Okay? So I would end up with something x to the 5th. I don't care what else. I only care about this is degree 5. Okay? The other thing we care about is called the leading coefficient. What do you guys think the leading coefficient would be? The number before the highest power of x. Okay?
It would be 3, wouldn't it? Or 6. No, never mind.
So the leading coefficient is the coefficient of the highest power of x. So let's go back and what's the leading coefficient of these?
Well, the leading coefficient of 1 would be 4, wouldn't it?
Mm-hmm. Leading coefficient of 1 would be 4, because it's 4x to the 4th. Number 2 we can ignore, because it's not a polynomial. What about 3? What's going on with 3?
It would be 6, wouldn't it?
It would be minus 3. How did I get minus 3?
Beats me.
You got a 3 here.
Uh-huh.
Times 1. Times 1. Times coefficient here. Negative 1. Negative 1. Negative 1.
Huh.
So you really do have to write all.
So that was a 3, 2 1s, and 3 negative 1s. 3 negatives is
Negative.
negative 3. Okay? So just look at, you imagine multiplying all the x's together, imagine multiplying all the coefficients of x together. So all the coefficients are just 1, 1, negative 1, times negative 1, times negative 1.
Could you say because it's an odd number, it would be a negative?
It's an odd number of negatives, yeah.
Yeah, so that would make it a negative answer.
Okay? Negative 3. It's all because that 2 minus the x, that x has coefficient of negative 1 in all of this. Now let's talk about some other features of polynomials. So we talked about degree and leading coefficients. Let's talk about the maximum number of zeros.
x-intercepts?
X-intercepts.
So the maximum of zeros would be the same as your highest degree.
Your degree, right. The degree tells you the maximum number of zeros. Like a quadratic has degree 2, it can have 2 x-intercepts. Cubic has degree 3.
No, that's it can. It's not it will.
It can. It doesn't have to. Okay, the maximum number. Now the maximum just means at most. It doesn't mean it has to equal that number. Okay, what about turning points? Do you guys know what turning points mean?
Changing direction.
Changing direction.
From these.
Like the vertex.
From the vertex? Okay. In quadratic, it would be
How many
2.
how many turning points would a quadratic have?
2.
1. The vertex. Where quadratic changes direction once at the vertex.
Okay.
The maximum number of turning points is 1 less than the degree. So if your degree is 2, you have 1 turning point. You change direction once.
What if it's your degree is 0? Would it be -1 or 0?
That would be 0. Because the degree 0 would just be a horizontal line. That doesn't change direction at all. So it's the maximum number of turning points, but it could be less than that. Okay, so if your degree is 3, you could change direction twice. If your degree is 4, you could change direction 3 times, and so on. Okay? What's the next thing we want to talk about? How about the end behavior?
Jeez.
That sounds kind of ominous, doesn't it? What do you guys think end behavior might mean? The end behavior is what the graph is doing on the left and right. Like up on both sides, down on both sides, up, down, up. Those are the 4 possibilities.
Could you go into more detail about that?
We're going to.
What did I?
Okay, you're talking about as x gets big or small. So when you go to the left and the right, what is the graph doing? Is it going up or down?
When x gets what?
Bigger.
Concave up and down?
Yeah, it's like concave up or down. When x gets bigger than smaller, you're talking about what is the graph doing? Is it going up? Is it going down? Is it going in opposite direction?
It could be either way.
It could be either way.
Wouldn't it have an inverse always?
Just roll with it for a second.
Okay.
Okay, the end behavior depends on whether the degree is even or odd. And whether the leading coefficient is positive or negative. Okay? So you need to look at even or odd and then also positive or negative.
Whew. This is getting complicated.
Alright, let me get a second to write that down.
got a question. If yours is just like x cubed, your leading coefficient, okay, like this is what I typed in just to see what it would look like.
Leading coefficient would be 1.
Would be 1 because there's nothing next to, there's no degree next to this end here. Right.
Right. So you only care about that x to the third in terms of what it's going to tell you. Alright, you guys got that down?
No.
Okay, so there's 4 possibilities. If you're looking at even, odd, and then also positive and negative. You've got even, positive. Give yourself some room here. We're going to make a chart. Even and negative. Odd and positive. Odd and negative. Okay, so let's make ourselves a little table here. Okay, even and positive, you're going to go up on both sides, like concave up parabola. Okay, so up on both sides would be like a parabola. The only other option would be if it had like a W thing in the middle. So you can get a parabola or you can get an extra bump in the middle. It has to go up on both sides. So you got even degree, positive leading coefficient.
So if it was even negative, would they both be going down?
Yep, negative just flips it upside down, just like the concave down. So you get the same pictures, they're just going to be flipped. So what if I change from even to odd?
It would be more of an S, wouldn't it?
They're going to go in opposite directions. So even goes in the same direction, odd goes in opposite direction. So odd and positive is up on the right, down on the left. Just like this. Okay? So my arrow is going up on the right side, down on the left side. And then changing that from positive to negative is just going to flip it upside down. So it's going to go down on the right, up on the left. Just like that.
Okay. So I guess these are just kind of like classifications of...
You just have to figure out what category are you in. So let's look at an example on the homework. There's a couple examples where they ask you questions like this. Alright, sweet. Look at homework 9. calculate the x-intercepts. Now we'll go into a lot more detail about how to actually find the x-intercepts next time. Today you just want to read them off the graph. So my x-intercepts here are -3, 1, and +3. So I just want to see those on the graph. Put a comma between them. Okay. Then, what would the sign of my leading coefficient be? And to figure this out, I want to look at what shape is my graph.
Negative.
So the shape of my graph is going up on the left, down on the right. Shape of my graph would look like that fourth category.
I'm liking this.
Yours may not look the same, but mine looks like the fourth one that we just talked about. So it'd have to be negative.
I mean, it's easy. Just look and point.
And it'd have to be odd.
It's cubic.
So if quartic is 4, cubic is 3, it'd have to be cubic, because 3 is odd, 4 would be even.
Another point to bring up there is cubic would have 3 x-intercepts, so this has 3 x-intercepts.
Well, quartic could also have 4. It could also have... Actually, no, it couldn't.
No, it couldn't. Quart.
They come in pairs. So it could have 4, 2, 0. It can't have 3. We're not gonna talk about that, but that is
Okay.
true. We're not gonna talk about why, but that is true.
I didn't know that. I was just saying cubic it could have 3.
Well, if it goes in opposite directions, it has to be odd. Cubic could have 3. Quartic technically could have 4 or fewer. So the fact that it only has 3 doesn't immediately rule it out. But it is true that they're always in pairs. So quartic can only have 4 or 2 or 0.
Okay.
Yeah. That's hard.
I'm smarter than I knew.
Well, no, that's not true.
What?
You're not smarter than you knew.
No. A quartic could have 3 x-intercepts.
It can? You just told me it can't.
I was wrong. What about this? That's a quartic with 3 x-intercepts. So yeah, I was wrong.
I guess if one of the...
I'm thinking of something else that I'm misremembering something.
Okay.
And one of them was just touching the axis. And that's a good point. We do need to talk about that. When do you know if they just touch the axis like that? There's a way you can tell.
Wouldn't cubic have exactly the same y values, just inverses of each other? Like here, my cubic,
Does it have to be symmetric?
yeah, because it's symmetric. It's a -3 or a +3 and -3. Wouldn't that be a cubic or a quadrant? Quartic.
Oh, it's a cubic.
Oh, no, it's a cubic,
Is
but...
it symmetric? Well, quartic could also be symmetric if it just dipped here and then went back up.
So I guess I'm not getting anything.
You mean the
I'm
3
trying to find...
and -3?
Yeah.
The height always have to be symmetric? No.
Okay.
Like this one could go farther up if it did. It just doesn't in that
cubic?
case.
You could do that in cubic?
It could, yeah.
Okay.
Like it could go like lower on this end or higher on this side.
So much for that theory.
Okay, one more thing we need to talk about, and that's behavior at the x-intercept. The graph may either cross the axis
This way the 28-minute video's got a lot of information.
Okay? So it can either cross the x-axis or touch the x-axis but not cross it.
Well, it's just an x-intercept wherever it touches it.
It's still an x-intercept. Okay? Now we're going to talk about that more next time. When we talk about actually finding the zeros, you'll have to figure out what actually is happening at those zeros.
Can you go back to just a second?
1 second, I'm looking for something here. Make sure that's not in this somewhere. No, it's in the next one. Okay. So just keep that in mind. It's still an x-intercept even if it just touches back here. So I hear you guys typing. It sounds like you're doing some of the homework problems. Are you getting through them pretty easily? There's a lot where you just punch it in the graphing calculator. That's pretty easy. There's some where it asks you questions where you just have to know all the rules that we just talked about. Do you guys remember how to put in the windows on the graph? Where it says something, something by something, something? Remember that means the x-min, x-max first, and then y-min, y-max? The only thing we really need to learn on the graph is how to estimate the turning point. So let's find let's look at number 12 here. Okay. Now 2 of these I can rule out right away. Why can I rule out 2 of these right away? My equation is x to the 4th minus 4x squared minus 6.
This is not negative, x.
The first x has a coefficient of positive 1. What is the degree here? 4. Okay? So I'm in the positive even category. Alright, which ones can I rule out? A and C. A and C would have odd degree because they're going in opposite directions. Okay? So I know A and C are out. I'm looking at either B and D. I don't actually know what the graph looks like, but I would bet money it's D. But let's try it. X to the 4th minus 4x squared minus 6, I think is what it was. And then negative 8 to 8 by negative 20 to 10. I'm going to do negative 8 to positive 8. And then on y, I want to do negative 20 to 10. Now, what did I do here? And I lost the number. That's why my graph looks crazy. There we go. Okay. Now, how many turning points does this have? 3? Okay. There's one here. Changes direction here. There's one in the middle here. And one here. So I've got 3 turning points. Can I have any more turning points than that?
No.
No. Okay, one less than the degree is the maximum. Alright, so that's my graph. I've got 3 turning points. Can I have more? No. A lot of these are just kind of the same question in just graph. What do they mean by a complete graph?
The basic shape, show the basic shape.
It shows the basic shape, it shows the turning points, it shows all that kind of stuff. leading coefficient?
Would be
Cubic and positive. Which ones can I rule out based on cubic and positive?
you could rule out A and D because those are both negative.
Cubic and positive would be down on the left, up on the right. So I can rule out A